The topic is bubble sort. So in this video, we will learn about bubble sort. I'll show you how it works upon this list of elements. Then also I will analyze. Let us see it's working. I have a list of elements, array of elements. 5 elements are there in an array. Now to understand how it works, I will draw this array vertically. So I will take these elements vertically. Indices are 0, 1, 2, 3, 4. I don't need indices. Without indices, we'll work on it. So let us start. See, it will compare a consecutive pair of elements every time. If the first element is greater than the second element, then it will interchange the element. So it will compare these two elements. 8 is greater than 5. So 5 will move up, 8 will come down. The remaining elements as it is. So this was the first comparison and the first element was found greater, so it has interchanged. Continue. Second comparison. 8 and 7. 8 is greater than 7. So 5, 7 comes up, 8 moves down, 3, 2. Then third comparison with the next element. So these are consecutive elements, so it will compare them. 5, 7, 3, 8, 2 because 8 was greater. Then compare these two. 5, 7, 3, 2, 8. So I have compared all the pair of elements. Total 5 elements are there and 4 possible pairs are there. So we have compared all possible pairs of elements. Right? So when all elements are compared once, then this is called as pass. Pass means we are going through the list. So this is the first time we are going through. So this is first pass. What is the result of the first pass? One element is sorted. Which element is sorted? Largest element is sorted. Heaviest element is sorted. That 8 is sorted in the list. So we have done 1, 2, 3, 4 comparisons. So we have performed 4 comparisons. So there are 5 elements, so we have performed 4 comparisons. That is, if there are n elements, then we have performed n minus 1 comparison. Then how many times swaps are done? Every comparison swap was done. 1, 2, 3, 4. This is the final result. So 4 swaps are also done. Now all elements are not sorted, just one element is sorted, that is 8. Then I have to continue and perform second pass. So I will take this list of elements once again. I will perform second pass. First compare these two elements. See, first one is not greater than the second one, so they are not swapped. They remain as it is. So if it is greater, we will swap. Then next pair, 7 and 3. 7 is greater. So 5, 3, 7, 2, 8. Then 7 with 2. 5, 3 as it is. As 7 is greater, so swap it. 2, 7 and 8. Then 7 and 8, if I compare also, no use because 8 is already sorted. I can avoid that comparison. So total 2 elements are sorted now, 7 and 8. 2 largest element I got. How many comparisons I have performed? 3 comparisons I have performed. Then how many swaps are done? Just 2 swap. Only 2 swaps are performed because here the number was smaller than 7. So at most how many swaps are possible? 3 swaps are possible. So I will write down 3 swaps. This is the maximum number of swaps, not the actual swaps that has happened there. Maximum swaps I am writing here. Now this was the second pass. 2 passes are completed. How many elements we got sorted? 2 elements got sorted. 8 and now 7 also. 7 and 8 are sorted. Now I will take the elements once again, continue this list and perform one more pass. 5, 3, 2, 7 and 8. Compare these two. 5 is greater. So 3 goes up, 5 comes down, 2 and 7 and 8. Then compare 5 with 2. So 5 is greater. So 2 and 5, 7 and 8. That's all. Stop. Because if you compare 5 with the 7 or 5 with 8 also, no use. They remain as it is. Now 3 elements are sorted. How many comparisons? 2 comparisons. How many swaps? Maximum 2 swaps. Yes. This was a third pass. I will perform one more pass. 3, 2, 5, 7, 8. Compare these two. 3 is greater. So 2, 3, 5, 7, 8. That's it. Comparing 3 with 5 is of no use because already sorted. So I'm not comparing with those elements which are already sorted. So right now, how many elements are sorted? I have sorted 1, 2, 3, 4 elements. But there is only one element left, so that is also sorted. So this whole list is sorted. How many comparisons we perform? Only one comparison. How many swaps are done? One swap is done. That's all. The list is sorted. So this is the working of bubble sort. Using 5 elements I have explained you. Let us analyze this one and study each and everything of this one. First of all, how many number of passes I have performed? Total 4 passes. 1, 2, 3, 4. I have performed 4 passes. If I separate them like this, you can see them clearly. I have performed total 4 passes. Then how many elements I have? I did not write that. I have 5 elements. So n is 5. See, actually when we are doing analysis, we should do it for n elements. N means whatever the number of elements may be. In our example, we have only 5 elements. So for 5 elements, 4 passes are there. Then for n elements, how many passes will be there? N minus 1 passes will be there. So this is n minus 1 passes. Yes, this is perfect. Then let us find out number of comparisons. See, if I start from here 4, 3, 2, 1. If I count from that side 1, 2, 3, 4. So total comparisons are 1 here, then plus 2, then plus 3, then plus 4. 1 plus 2 plus 3 plus 4. Then for n elements, how many? 1 plus 2 plus 3 plus goes on to. See, for 5, it was up to 4. So for n, it will be n minus 1. This is sum of first n natural numbers up to n minus 1. So this is n into n minus 1 by 2. So this is order of n square. See, this I got a formula. Formula is polynomial. What is the degree of a polynomial? N square. So I wrote it as order of n square. Then next is number of swaps. How many swaps are performed? See, actually this is maximum number of swaps, right? Here you can observe that there were only 2 swaps, but I wrote 3. So 3 were possible. So I am writing maximum number of swaps. So maximum how many swaps are there? Again from there, if I count 1 plus 2 plus 3 plus 4. So 1 plus 2 plus 3 plus 4. For n elements, 1 plus 2 plus 3 plus goes on to n minus 1. Then this is also n into n minus 1 by 2. So this is also order of n square. See, number of comparisons are also n square. Number of swaps are also n square. See, from the criteria, I have checked 2 things. How many comparisons? How many swaps? And the time complexity of any sorting algorithm is given based on number of comparisons. So the time taken by this algorithm is n square. Now, out of 5 criteria that we have seen in our first video of this section, I have completed 2 criteria, comparisons and swaps. Remaining 3 are there, whether it is adaptive or not, whether it is stable or not, whether it is taking extra memory. These things we have to discuss. So before going to that analysis, let me discuss few interesting things about bubble sort. See, first one, why it is called as bubble sort. See, this was the list of elements. This was the list, right? This one. 8 is heaviest element. So if you drop it from here, it is going down and settling at the bottom. And the other elements like 2, 3, 7, 5, they are lighter elements. So they are slowly moving up. So they are moving up. So the effect is just like if you throw a stone in water, then stone is heavier, so it will go and settle at the bed. Then the bubbles which are lighter will come up. So that's why the name of this sort is bubble sort. The effect is just like bubbles in water when a heavy thing is thrown in water. I don't know who observed this and given the name, but this is what the observation based on which the name bubble sort is given. This is the name. One more interesting thing. In one pass, I got the largest element. Then second pass, I got 2 largest element. Third pass, 3 largest element. For some n elements, if I perform k passes, then what I get? K largest elements I get. K largest element. Suppose you have a list and you don't want to sort everything, just you want which is greatest. Just perform one pass. I want first three greatest number. Perform three passes and stop. So you can take the help of this procedure, this algorithm, for performing selected number of passes to get desired result or required result. Now I will remove these things, then I will just write on a piece of code showing bubble sort, working of bubble sort. I'll remove this and show you. I have a function for bubble sort. So what is the work we are doing in this one? We are performing n-1 passes. So we have to repeat something that is passes for n-1 time. So I will write on for loop directly. This for loop is for passes. For I assign 0, I less than n-1. If there are n elements, then n-1 passes we have to perform. So this will be repeating for n-1 time. Then in each pass what I have to do? I have to compare this element with the next element. So if I say this is j, then compare it with j plus 1. Then again bring j here and j plus 1. Then bring j here, then j plus 1. So I need one more loop for comparing all the elements, consecutive pair of elements every time. So I will take one more for loop for j. Now for j assign 0, j less than n-1, j plus plus. So this j will be moving along these elements. Here also I wrote n-1 because if there are 5 elements, then I should perform only 4 comparisons. Yes, correct. But one more thing, in the next pass, one comparison should reduce. Then again next pass, one comparison should reduce. So in every pass, one comparison should reduce. So not just n-1, minus I also. So it means first time in first pass, I 0, so nothing is subtracted. Next pass, I will be 1, so 1 will be subtracted. So this becomes n-2. So j minus n minus 1 minus I. Why I? Because in every pass, one comparison should reduce. Next, what I should do inside this loop? I should compare a of j with a of j plus 1. If a of j is greater, then swap. So here check if. So I have written the statement. If a of j is greater than a of j plus 1, then swap them. Swap means 3 statements I have to write on. Instead of writing 3 statements, I just wrote swap. So swap the elements a of j with a of j plus 1. That's it. So logic is very simple for bubble sort. And you can see that there are 2 nested for loops. For loop is there, then inside that one more for loop is there. So from the code, if you see, if you have 2 for loops that are nested, then the time is n square. And both are working based on n only. N. So time is order of n square. From the code also you can see this one. Next. So I have written the code. Now next thing, let us understand whether it is adaptive or not. So for that, I will take a list which is already sorted. See, this list is already sorted. Right? Let us perform bubble sort on this one. And we will perform first pass. First pass. So in first pass, compare these 2 elements. Swapping is required? No, this is not greater. So write the elements as it is. Next, compare these 2 elements. Is it greater than this one? No. So write down the elements as it is. Can you tell me this comparison and swapping, where it is happening? In the outer for loop or inner for loop? Yes, it is happening inside inner for loop. This is j. See, this was j was here, right? So j plus 1. Next time j was here, j then j plus 1. So this is happening inside this loop, inner for loop. And this condition is not true. This condition has failed. First time also the condition was false. Second time also condition is false. Then again check next. So j should come on this one, right? So j should come on this one. Compare these 2. So these 2 are compared, j with j plus 1. J with j plus 1. Is it greater? No. So swapping will not happen. So elements are as it is. The next j is here on this one, right? Compare these 2. Then is it greater than this one? Is it greater than that one? No. So it will not swap. So the elements are as it is. So we have completed one pass, and in this entire pass there was no swapping done at all. So it means inside this for loop swap was never done. Swap was not done at all. No swap was done. If no swapping is done means we can say that the elements were already sorted. That is the reason swapping is not done. Yes, yes. We can identify that if the list is already sorted or not. If there is no swapping, then the list is already sorted. So for that, I will take one variable called flag. This flag variable, I will initialize it to 0 before entering into a pass. This loop is performing pass, right? This is for repeating the passes. This loop is for comparison. See, just now we have done all these. So this is happening in this one. So before starting this, make flag as 0. And if any swap is happening, make flag as 1. Means there is some swapping done. Then outside this for loop, there is no space here. So I will write on here. Outside this for loop, check if a flag is still 0, means swapping was never done. We can identify like this. So here I will write on, if flag is still 0, then break or stop or return, whatever you want, you can do it. Then closing of outer for loop, then closing of function. So I can use one flag variable and make the flag as 0 before every pass, and inside this for loop, if swapping is done, then I will make flag as 1. Outside this for loop, outside this inner for loop, once the pass has finished, check if a flag is still 0 when swapping was not done, and break. Break means it will come out of this outer loop also and function stops, or else you can say simply return. So by introducing a flag, we can identify whether there was any swapping in a pass or not. If no swapping means list is already sorted. So this may happen in first pass or second pass. In any pass it may happen. Whenever it is happening, it will stop. If the list is already sorted, then it will stop after first pass only. Now analysis. What is the time taken if the list is already sorted? It is performing just one pass and it will break. So in one pass, how many comparison on how many swaps? Number of comparisons are n-1. Swaps 0. So it's not performing any swap. 0 swaps. So n-1 comparison means the time is how much? Order of n. So we can now say that bubble sort time. Minimum time taken by bubble sort is order of n. Maximum time taken by bubble sort is order of n square. This n square already we have seen. Then n is now we are looking at. It is taking order of n. When? If the list is already sorted. So bubble sort is having minimum time also, maximum time also. So if the list is already sorted, then it is taking minimum time. So bubble sort is adaptive. Yes, bubble sort is adaptive. So this is adaptive. Yes, true. So by itself it was adaptive, or we made it by using flag. We made it by using flag. So we can make bubble sort as adaptive. By default it is, by nature it is not adaptive. We made it. So it is possible to make bubble sort as adaptive, and the bubble sort is known as adaptive algorithm. Then one last thing, whether it is stable or not. To study whether it is stable or not, I have taken a list of elements. Let us see the list. See, there are duplicate elements. So let us start bubble sort on this one. So first pass, first it will compare the elements, this element. If first is greater than second one, then interchange. But first one is not greater than second one. It will not interchange. So I will do one thing. I will write this 8 with red color so that you can identify. So will it interchange? It will not interchange. That black 8 remains as it is. Then red 8. Then 3, 5, 4. Then it will compare these two. Then this 8 goes down. So 8, 3, 8, 5, 4. Yes. So that was first 8 remains there only, right? The second 8 will come at the bottom. Then above that, that first 8 will come. So their order is not changing. It's not switching the elements like this red 8 is coming first, then this black 8. They are not changing the order. This will not happen. Because if this is greater, then only it will interchange. So bubble sort will interchange only if the first element is greater than the second element. So that's how bubble sort is stable also. So yes, it is stable. So bubble sort is adaptive, bubble sort is stable. That's all about bubble sort.